So, good afternoon, everyone. Welcome to this Quickie. My name is Xavier Coulon, and so with Quickie we built HTTP caching in practice. So, you're going to use caching in HTTP because you want to improve performance, of course. So this would be like if you want to improve performance and scalability of your platform, if you want to reduce the load on your servers, or even if you want to resist to any crash, or even keep serving content when you are redeploying your applications. There are four types of caches. Local cache is a cache you get in your browser. Proxy cache is a cache that you have, for example, if you are in a corporate environment and you're trying to access remote resources outside of your network. So you may go through a proxy and the proxy may cache the content. Gateway caches, on the other side, is a cache that you will put in front of your servers if you want to serve content and not get requests on your servers, on your application server. And application cache is something else. It's something where you will maybe cache some internal content of your application or maybe some backup, some backend data. So there are two natural mechanisms to cache content. One is called expiration mechanism, and the idea is to avoid sending requests or too many requests. So, for example, a client is going to request to try to get some resources, and the server is going to reply with an HTTP response. And it will include some headers, such as last modified and an expires header. And this expire header is going to contain a date in the future. And so in subsequent requests, when the client is going to request the same resource, it's just going to use its local cache instead of sending a full request to the server or to the origin server. The second mechanism is a validation mechanism. And the idea in this case is to avoid sending full responses. So the first way to do it is to use the if modified since header. So once again, our client is going to send a request to get some resource, and the origin server is going to reply with the last modified header in the response. And in subsequent requests, the user agent is going to include a if modified since header using the same data as it got in the previous response. And if the content didn't change on the origin server will reply with a 3 or 4 not modified response. So instead of sending once again a full response with the full content, it's just going to send a short response. So you will save processing time and bandwidth. The other way to use a validation mechanism is based on e-tags. So once again, our user agent is going to send a GET request for some resource, and the origin server is going to reply with an e-tag header in the response. So the e-tag can be something like a timestamp, or it can be something based on some custom algorithm. It doesn't matter really. You have two types of e-tags, strong and weak. So a weak e-tag will start with a w/prefix. And the difference is a strong e-tag means, a weak e-tag will mean that the content didn't change semantically. Maybe some internal content moved, but the resource is the same. Now, in subsequent requests, when the client is going to try to get some resource, it's going to include this if non-match header in the request using the same e-tag as before. And the origin server may reply with a 3 or 4 not modified if nothing changed on the server once again, if the resource did not change. There is another use case for the e-tag. And so once again, we get the same request response mechanism, exchange, using the same e-tag value in my example. And in this case, the user agent is going to try to modify the resource it got before. And it's going to send the if match header in the request. But if someone changed the resource on the origin server in the meantime, in between the get and the post requests, then the server can reply with a 412 error message which is precondition failed, which means that the resource changed. And so this is a good way to manage concurrent modifications of a given resource on a server. So what we've seen so far is you can cache response for GET request, and cache will reply with the most up-to-date version of the resource that it has. But it's the most up-to-date, it's not always the latest one. So this means that cache can lead to inconsistencies. So when I talk about cache, I talk about local cache and maybe proxy caches in between the user agent and the origin server. So cache lead to inconsistencies, and this is something you really need to care about. Fortunately, expiration and validation mechanisms are what are called server-side implicit directives, but fortunately there are explicit client and server directives that you can use if you want to override the default caching algorithms. And to do this, you get the cache control header that you can use in request, and you can set some value for the cache control header, such as no cache, which will mean that you are going to send a request. I mean, the user agent is going to send a request, and using the cache control no cache header, no cache between the user agent and the origin server can be used to return the resource. So in this case, you really want to get the latest version on the origin server. You can also use other values, which I won't go into in detail now. You can also use cache control response, cache control header in the responses. So this time, the origin server may specify how cache between the server and the user agent may behave for the given response. So for example, if you set a public value for the cache control, it means that any cache proxy between the origin server and the user agent may cache this content. If you set a private value, it means that no cache proxy in between the user agent and the origin server may cache the value, but the resource may be cached by the user agent using its local cache. And of course, if you set the no cache value, it means that the resource can never be cached by anyone on the path. There is also the old pragma header, which can be used in requests and responses. So there is pragma no cache. It's basically the same as cache control no cache header, but it's only used for HTTP 1.0 backward compatibility. So for example, if your user agent is going to hit an old HTTP 1.0 web server. So there is a small trick here. If you use the refresh action or button on your web browser, the web browser is going to include a cache control max age equals 0 in the request. Or if you do something like shift refresh, it's going to use cache control no cache in the request. It's also going to use the pragma no cache. And this header will be used in any request for any resource required to build the page. So you are sure to get maybe, you're sure to get the latest versions on the origin server, but this cache control header is not included in any AJAX requests that will be used, will be sent by your JavaScript client once the page is built. So this is something a bit you need to care about as well. So on the Java side, there are some ways to work with headers, to include headers. So one way to do it, if you do some servlet-free code, is to use web filters. So in this small example, we see that any CSS, font, and JS resources are going to have an expire header in the response, and this expire header is set like 1 year ahead, so basically it never expires. So this is for static content, and then the user agent is going to keep this in its local cache. Now, if you play with the JAX-RS2 API, there is a new JAX-RS2 interceptors that you can use, and the nice thing about interceptors is basically it's kind of filters, servlet filters, but specific for JAX-RS resource methods. And what you can do with Java EE7 and JAX-RS2 is you can imagine that you have some cache service that you inject in your response filter, and you're going to include an e-tag in the response. So this is one way to return e-tag in any request, in any response to user agents. And then you can use these e-tags in some request filters and check if nothing changed between the last response and the new request. Then you can send, you can abort the processing, which means that no further processing will be executed on the server side, and you can abort with a 3 or 4 not modified response. So, what about HTTPS? HTTPS works, also provides support for caching, obviously, but the difference is if you have any proxy cache server, cache proxy between your origin server and the user agent, those proxies won't be allowed to cache the content. So you have to decide what you want to do with static resources. Do you want to use HTTPS and not provide support for gateway caching or proxy caching in front of your servers, but put everything in HTTPS, in which case it's fine because the content can be cached by the user agent, by each user agent, which means that each user agent is going to send a request, some request for the resources, but then everything is on HTTPS. Or you can use a mix of HTTP and HTTPS for static resources on HTTP and private secured content on HTTPS, but then you get some warning from the browser. I made a demo, but I don't have time to show it today, but the code is on GitHub on my account if you want to look at it, and you will get AngularJS front-end with JAX-RS2 backend, and it's running on Wildfly if you want to play with it. So let's go to the conclusion. What you can do with caching is be aggressive with static content, which means you should use expire headers. You should allow for gateway caching, so having cache servers in front of your application server, and put something like cache control public, maybe max age with a delta in seconds. So for static content, so basically if you have some cache server in front, your application server may be hit once or just one time, and then everything will be served by proxy cache or gateway cache in front of your application server. And then for dynamic content, that's up to you. You have to decide, depending on your use case, if you want to use cache control header with value such as no cache, if you want to make sure that your user agent or the clients are going to get the always latest version of the resource, or if you accept that a user agent gets something which is a bit out of date but still acceptable. So you have to decide. If you have a blog, for example, or CMS, maybe having a page which is not the very latest version but something like 1 or 2 minutes ago, and maybe the user won't see the latest news or something like this, it could be acceptable. It's up to you to decide. And of course, you can use also e-tag header if you want to revalidate content, make sure you don't have concurrent modifications on the resource. In your Java toolbox, you can use servlet filters, JAX-RS interceptors, as I showed you. If you're still using JAX-RS 1.1, you don't get interceptors, but JAX-RS implementations such as Jersey or REST-easy have something which is quite similar to interceptors. And in fact, interceptors came from custom implementations. So you get something similar. And if you want to do some testing, Aquilian is good for this. And there is a new REST extension for Aquilian, or there is a REST assured library which provides you with a Fluent API if you want to submit requests and make assertions on responses. If you want to read more about HTTP and HTTP caching, there is a RFC 2616, which is HTTP 1.1 specification, and it has a chapter for everything about caching. And that's it for today. Thank you very much. There's 1 minute left, or maybe less. So if you have any question, otherwise, okay. Thank you very much and have a good conference. And enjoy the beers.